COVID-19 is spreading exponentially in the world. Due to this, most of the countries are running out of their hospital facilities. COVID-19 affects lungs, so patient needs artificial breathing unit called ventilator. Developing an artificial breathing unit, the main focus is on the quick reproduction of the unit in case of emergency. For this, I have brought an artificial manual breathing unit called AMBU bag. Using this, I'm going to make an automated artificial breathing unit. Let's open it and see. The main component is the bag. By pressing it, you can blow the air. This is the face mask. This bag is supposed to be attached behind the bag. This is called oxygen reservoir, and this is another valve, and this pipe is supposed to be connected to an oxygen cylinder and the back of the bag. Silicone bag, so it has a valve here and it's another valve here. It allows the flow of air from here to inside and from here to outside. So when you press, the air goes out. When you release it, the air goes in here from here. This is the face mask, so you have to keep it here like this, and the bag will be connected like this. This is to be connected from here to an oxygen cylinder. This is the oxygen reserve. It is supposed to be connected here, and this is the valve. Let us connect it and see. I have finished almost the assembly. So this is supposed to be connected here, and the other end of the pipe goes to oxygen cylinder. The oxygen comes through this pipe and all the way comes here and goes back, fill this bag. Now this bag will be filled with oxygen, and if there is an excess pressure, this valve will get opened, and if there's a very low pressure, the other valve will get open. So this is a valve for controlling oxygen pressure, basically the inlet pressure to this silicone bag. Now if you press, some air will go through this, and if you relax it, air comes from here, and this part of the body is supposed to go to the face of a patient, so this can like orient in any direction, and this goes here, though it goes to the face. So this is the protocol. So when you press, the air goes from here all the way in and goes into the lungs of the patient. So there will be like excess pressure in the lungs, and when he exhales it out, the gas comes here, and there's another valve here that allows the gas to go out. So there won't be any backflow from here to the bag. Whatever the gas comes from the lungs will goes through this, and there's a valve and comes out of here like this to the out. So this is all about it. Now I'm going to automate it. So the basic design is there will be like a shaft, and which is going to press it automatically. Here is my setup. I use a 12-volt battery, which is generally used for bike and scooters, and then I use an Arduino UNO, which is kept here. So if you want, I can show it. So this is Arduino UNO, and this is a NEMA 17 stepper motor. This is V3 CNC sheet, and these are like the Pololu stepper motor controller. So there's a wire which is coming from battery, so which basically powers this stepper motor controller and Arduino through this wire, and we have another wire here. This is only used to, for programming from computer to the Arduino. So the setup looked like this. So I used a vegetable cutting board. So I have made a couple of holes, and there are 3 holes to mount Arduino. There are 4 holes to just connect the stepper motor here. So I use a normal cable tie. This is a quick setup. This other part of the stepper motor, there's a shaft, and I used some bush which we generally keep underneath the wooden table, underneath the legs of the wooden table, which is this is that bush, the plastic bush, and which is connected to the stepper motor. There's a ribbon, which this ribbon is generally like whatever we have, this ID card tag, those kind of ribbon. And here is 2 stand. Basically this is what we use for mounting curtains to this window. The window curtain, you mount this one of the stand on one side, the stand on other side, and you put the rail and mount the curtain there. And the same thing, and this is a wiring PVC, and this is a wiring PVC T. So I connect a T here and just another PVC here, so that I can have this motion. At the moment what it does, the stepper motor rotates and press the AMBU bag. AMBU bag is supposed to sit here, and when it releases. Okay, this is the protocol we are going to do this process. And for a better design, we need to have slightly shaft which is like slightly bent like this. That will be a better design, and if it can press from both sides, that will be a better design. Let's look into it. So I'm going to mount this. This is the CNC shield to the Arduino. So I have already made the wiring. So I've mounted the CNC shield, and from one stepper motor controller I have made connection to the stepper motor, and this is here, and this I want to interface with PC, and this I want to power this one. Okay, so now the design goes like this. So it's here, and the AMBU bag, so this is supposed to be inflated. Fine, I'm going to sit like this. Now I have to program it. So this I'll hook up to a PC. Fine, I have already written the program. I just burn into it. So go compile and upload. So this program is currently uploading through this to this one. Yeah, done compiling. So we don't need it anymore. Fine, we don't need it. For your convenience, I'll keep it like this, and I have to power the Arduino. What is its power? It's supposed to be here. I'm going to hook up to the battery, and this is negative, so the black one is negative. It's going here, and this other one is positive. Yeah. So this is the operation. So you can see when you press it, air comes out, and when you relax, the air comes from here to here. Remember, this AMBU bag, this setup works fine at the moment, but there are a lot of things to tune. The time of inhalation and exhalation and the pause in between, and there are a couple of more designs to be improved. Like I need to have a slightly better bending, so those kind of things has to be tuned a little bit. So I'll be doing that. This is not a perfect system. In case of emergency, we can use it and produce it in a large number in a very short time, and that is the advantage of this. So if you have any comments and any queries or any suggestions, please comment below. Thank you so much.